Well, I got problem 16 to 81, one of the challenge problems, which was if the smallest time change is that scientists can reliably measure is 1 second, what's the smallest change in average temperature that can be measured? Um, Given that, and we're also given the fact that the sound, the waves traveling that we're doing is 8,000 kilometers, which you're going to want to convert that to meters to get uh, to put everything in the same units. With that thinking, you could also change your meters a second to kilometers a second if you want, but it's just change your kilometers to meters, so you get about 8 million meters. So what you're going to want to do is you're going to want to utilize the fact that you have to find your time, you have to find your velocity, because so the velocity that we're given initially is 1,480 meters a second, right? Let me just start showing you the paper, right? So then, really what you're going to be doing here is you want to find the time, because we're told that the smallest time change you can find is 1 second. So we want to find the time for given our initial values, right? So 8 millimeters over 1,480 meters a second, and that's going to give us 5,405 seconds. However, since the smallest temperature taken accurate measure is 1 second, we're going to subtract 1 from that. I'm sorry, that's kind of fast. We're going to subtract 1 from that, and we are going to use that as our new time. Since we have a new time, we need to find our new velocity, because the velocity can't be the same if the time changed and the distance didn't change. So we find a new velocity using 5,404 meters a second, and then you're going to get 1,480.38 meters a second. I rounded it up to 1,480.4 meters a second, and now you're going to want to find the difference between those two, which was 1,480.4 minus 1,480 is 0.4. So difference is 0.4 meters a second in your velocity. So your difference in velocity is that. So now that you have that, you have to remember that since the big part of the problem here, since since for every 1 degree Celsius that it goes up, you're going to get a 4 meter a second change in velocity. For every 1 degree Celsius that the temperature goes up, you're going to get a higher velocity of 4 meters per second. So, utilizing that, you want to find the temperature, and since the velocity or the difference in velocity is equal to the difference in velocity. Difference in velocity from the first part times the temperature in Celsius. I'm sorry, you can see that here. I kind of wrote it here, but I put the wrong symbol here. So our velocity, or our is equal to change in velocity found over here, and times our temperature Celsius. So you want to rearrange that. You're going to get temperature Celsius equal to the change in the velocities you found up here over 4.0 meters a second, because that's the velocity that we're using, because that's how much the velocity goes up. I hope I explained it better in that part. And then you're going to get 0.4. I messed up when I first did this problem. I put 0.3 because I was doing it really fast. 0.3 or 0.4 really. 0.4 over 4.0 meters a second, because that's a change. And you're going to get about 1 degree Celsius as your smallest average temperature that you can read. Smallest change in average temperature that can be measured. There you go. That is the problem. That's how you do it. I guess really big trouble here was finding how you're going to do that, because in the textbook it gives you speed of sound, and it gives you the speed of sound, and that's a kind of different equation. But you do have to utilize temperature Celsius with all this when you're finding the speed of sound going through a medium. Speed of sound travels faster through water than it does through air, a lot faster. It's like 1,480 meters a second, and in air it's like 340 meters a second. So that's just something to note. Anyways, thank you. Any questions? Well, tell me in the review. Thank you.